Hey guys, it's Cameron here, and I'm bored, and I'm waiting on parts.
So, ball joints are messed up. They're pretty bad. So gotta put new ball joints in her. So, we gotta take it all apart anyway. So the decision was made that instead of just putting in new ball joints, like a normal person, let's lower it. We got brand new coils. We got brand new shocks. We got brand new shackles. I don't know if we need any steering though. I guess we'll have to see. Maybe. You know what? Yeah. Yeah, we'll see.
So, in my boredom, I decided I wanted to do a shorter video on how to do some of the things I do in Kerbal Space Program, like orbits, rendezvousing, docking, how orbits work really. Now, I know there's a lot of videos out there that already do this and already explain it well, and I'm not going to lie, I'm not the best teacher or explainer when it comes to technical things because I tend to use technical jargon that nobody understands. So, just bear with me. I'll see if what I can do. I'm going to take a stab at it here because I did get some suggestions. Some people have been asking me to do this kind of video. So here you go. And Joe, also, if you're listening, please pay attention. This is very important for you if you want to get good at the game. So with that being said, let's jump right into it. So what is an orbit? Well, an orbit is actually just circular motion if you think about it. Circular motion is made up of just two forces, or three, I guess, if you're in three dimensions. But in orbits, you don't really have that. You just go by inclination. So you'll have your radial force, which is drawn out on the screen here by that arrow, also known as gravity in this case. Yes, gravity is your radial force. And then you'll have your tangential force, which in this case is the acceleration, or not the acceleration, the velocity of my object or my spacecraft in this scenario, and that's what's keeping it in orbit. So it's just the forces of all the forces equal zero, right? Physics just that's why you feel weightlessness when you're in space, because there's no forces acting upon you that are unequal or unbalanced. So that's how you stay in orbit. So with that being said, we can now switch to how to plan maneuver nodes and burn your vectors. So now I've got this little spacecraft in an orbit that is lower than my space station that's also in orbit here. And if we just play with our maneuver nodes here, we can see that prograde increases our apogee, and then our retrograde actually decreases it. So, and then if we go to our normal vector here, it'll burn upwards, and it'll increase our give us positive inclination essentially, and then there we go with our anti-normal, that'll give us negative inclination. And now here's the radial in and radial out. Those are kind of weird because it shifts your orbit. Do you see how it's just, if I keep playing with these two maneuver nodes, it shifts the orbit? So that's kind of weird, orbital mechanics thing, and it doesn't really change your eccentricity. It was in my case because Earth is right there giving me a little bit of a gravity boost, but that's it. So now I'm showing you the vectors here on your nav ball. Retrograde, there's normal, and then there's anti-normal, and then there's radial out, and then there's radial in. So all the vectors are on your nav ball. If you're playing in career mode, you don't start out with those right away. But now let's just burn into let's give ourselves a little bit of eccentricity here, or not eccentricity, inclination, because there's something about this game that's pretty cool that a lot of people don't know about, and these little ascending nodes. So what those ascending nodes mean is that's where the point your orbit starts ascending or descending in comparison to your target. So in my case, the space station has an inclination of 0, which means it's orbiting exactly around the equator, whereas mine has what looks to be about 2.5 degrees of inclination. So now if I burn at that rising and ascending node, I can actually level out my inclination and get it all lined up again with that spacecraft. See how I did that there? So that's what I do when you're trying to do inclination changes. And then now when you're trying to rendezvous with a spacecraft or two objects in space, you wanna catch up with it. You want to get close to it. So now I'm going to show you, see, if I get into a higher orbit here, actually, I will start moving away from the spacecraft. The distance will start increasing. And that's Kepler's laws of planetary motion there, kind of. You know, things move slower the further away. So you actually have to, you know, slow down to actually increase your speed to catch up with the spacecraft, and that's because of gravity. I'm closer to the gravity well, which means I'm moving faster. So and I'm actually moving the same distance, just faster, right? And then so basically, what we're gonna do is we're just gonna try to catch up here and try to and try to align ourselves so that way we can burn and get a nice encounter with that. So now, if you can think of this as planets, a large scale, right? The Kerbin would be the sun, and my space station would be, let's say, like Duna or something, right? And let's just say my spacecraft is the Kerbin, right? This is what you're going to want to do when you're trying to get an encounter with Duna or another planet or whatever. You're going to need to basically see how all I'm doing is I'm just basically boosting my orbit up or boosting my orbit down, whichever way. Basically changing my my apoapsis in respect to the main body that I'm orbiting. So in this case, I'm orbiting Kerbin, so I got to increase my apogee to get that encounter with the spacecraft or with my space station. And this is kind of hard for some people to visualize and see at first, but once you do it, you really understand it, because basically, see, now I'm just coming up to that maneuver node, and like, let's just say this would be Kerbin, see, right? And then my space station is Duna, right? You gotta burn in that direction, basically increasing your orbit. See how I'm doing a mostly prograde burn. It's basically the same concept when you're doing planetary transfers too. You just you got to get into an orbit of Kerbin first, of course, and then you just set up your maneuver node so you do basically a prograde burn in respect to the sun, right? And so that's kind of how I like to visualize it. It might not be the best explanation. Like I said, guys, I'm not a teacher. I'm really bad at teaching, and hopefully this makes some sort of sense. I don't seem to be wanting to talk today very well, so there's also that. But anyway, yeah, so now I got that nice close encounter. Now, if you're in a planetary body, obviously you'll have gravity you have to deal with, a sphere of influence, which actually helps you out because then you can maintain a stable orbit. In my case, there's no gravity near the space station, or there's not a lot of gravity. In the game, there's none because, you know, gravity is a weird thing in the game. But in real life, there would be slight amount of gravity, right? Anything that has mass has gravity. And but it wouldn't be enough to get into a stable orbit. The tidal effects from the Earth or wherever you're orbiting would just completely destroy your stable orbit. So there's no chance of really getting into a stable orbit around a space station or anything like that. But you can use your engines, like I'm doing here, to basically push yourself around. So now what I'm doing is I'm actually, I got a nice and close encounter. Then I basically targeted, I set my vectors to the target. I burned towards my target, got even closer, and now I'm very close. So then you set that the docking port that you want to dock to, set that as your target. That's very important because that's how you basically see where you are. Now, from this point on, I'm basically only using my nav ball. Some people try to eyeball this by just looking at it. I wouldn't recommend it. I just use everything on your nav ball. It'll give you plenty of information. It tells you your velocity, and then it shows you your prograde, retrograde vectors with your target, and then it also shows you that little indicator in the center is where the nose of your ship is, right? So what I do is right now I'm moving backwards, so that retrograde vector, I want it to be on the opposite side of where that target node is, right? And then when I start boosting towards it, now I want that prograde to be, see how I'm using that prograde vector to push that target slowly closer to where my nose is. That's all I'm doing. I'm just keeping my eye on that nav ball, keep my eye on the speed. You don't want to be going too fast. And then once it's lined up, and if you noticed, right before I started doing all my maneuvers, I kind of roughly lined myself up with the docking port. That's recommended, just because, you know, things can go bad if you're not aligned good. And then now I'm just kind of boop, boop myself, you know, into a nice little straight line. I don't know what to say. And then once I get close enough, I just switch to target the target, I guess, and then come in for that nice docking. And that's how it's done, boys. So I'm going to call it good for now. Hopefully you guys found this helpful. If you don't know anything about orbits and how they work already, please let me know if you want to see any more of this. Like I said, I'm not a good teacher. I'm sorry. But anyway, guys, thanks for watching. Let me know if you have any other suggestions too, any other things you want to see me do. Then like this video, please, if you liked it. And then subscribe if you haven't already. And stay tuned. Thanks, guys.